moving on with our triangles. Now we're going to start getting our triangles congruent, which eventually is going to get us into some proofs. So first things first, we need to know what makes a polygon or a triangle congruent. Well, two polygons or two triangles are congruent. See my funny if here? Whenever you see this if, that means if and only if. So I got the two F's. If and only if. So two polygons are congruent if and only if their corresponding parts are congruent. And when I say corresponding parts, I'm talking about the angles and I'm talking about the sides. So let's look at two triangles that are congruent here. So if you notice, see all my little dash marks? If you notice for angle A, that has one little dash or one little kind of half circle-y thing there. And then I look over to angle D, that also has one little dash there in the angle. That means that those angles are congruent. So I could say that angle A is congruent to angle D. They correspond. Same thing with C and F. C has two little dashes, F has two little dashes. So they would be the same, or they correspond. So angle C is congruent to angle F. And lastly, B with E. So angle B is congruent to angle E. And then the same thing kind of works with my sides. I have dash marks. So when there's one dash with BC and FE, I could say, well, I gotta be careful here. So if I say BC is congruent, should I say FE or EF? Well, if you notice, I went B and then C. And B has the three hashes for the angle. So I want to say EF because E has the three hashes for the angle. So I'm going to go EF to be consistent. EF. Because B and E correspond, don't they? B and E correspond and C and F correspond. So it's nice to have those matched up like that. Then I'm looking at my other side nice, the two dashes. So if I say AB, that's congruent to, well, A corresponds to D, and here's my two dashes, so DE, and lastly, I said AC here, that is congruent to, or corresponds with this guy. And I started with A first, and A corresponds to D, so I'm going to start with D first, so DF. So all three angles have to be congruent to their corresponding angle, and all three sides have to be congruent to the corresponding side in the other triangle for them to be congruent. And when I state this triangle to be congruent to the other triangle, I state triangle, and I can do any order here, A, B, C. I'm going to just do that. But when I do my other one, they have to correspond. I'm going to switch some colors so we can see. A, B, C. So when I do this other triangle, I have to say triangle. Well, A corresponds to D. We just showed that. So I got to go D since I put A first. And I put B second, so B corresponds to E. So I got to say E. And then C corresponds to F, so F goes last. So they have to match up. So notice how A's first and D's first, because they correspond. B's second, E is second, C is third, F is third. They have to match up when I state that congruent statement. And that's going to help us. For example, in a problem like this. In the diagram, it says triangle ITP is congruent to triangle NGO. Find the values of X and Y. So I got a lot of information here. The triangles are congruent. So I know all angles are congruent to other angles in that triangle, and all sides are congruent to other sides. But in order to figure out where I go with things, I need to use this congruent statement. So for example, I is congruent to angle N, isn't it? I know that angle I is congruent to angle N because they're in the same spot. They correspond. So if I look at I, it's going to be the same as N. So I know angle N is 65 degrees. And I also know that angle G is the same as angle T. I know angle T is congruent to angle G. And that should help us out because T is 75, so G has to be 75. Which means what? P and O are the same, these two angles. So So I know that this is going to equal 40 degrees because they're the same, aren't they? P and O correspond. So I can set 6y minus 14 equal to 40. And then we solve for y. So you notice how I use that congruence statement, that triangle congruence statement, to set up my equation to solve. And we end up with y equals 9. So there's one answer. Now to get the side, well, I know this part. I know x minus 2y. And that's for NG, right? That's for the segment NG. Well, here's NG. So that's going to correspond to IT, isn't it? Because those are the first two letters. So IT is right here. So I'm going to set that equal to 7.5. So x minus 2y equals 7.5. And then don't we just find what y was? It was 9. So I'm going to plug 9 in for y. So I got x minus 2 times 9 equals 7.5. This is 18. So x, I want to add my 18 over. All right, I got to solve for x. Don't know what I'm doing right now. Add 18, add 18. So x equals 25.5. There we go. So you have to use that congruent statement up here in order to figure out which corresponds with which. So I can tell where I can set things equal in order to solve. We have one theorem in this section. Should make sense, the third angles theorem. Because if two angles in one triangle are congruent to two angles of a second triangle, then the third angles have to be congruent. So basically, if angle A is congruent to angle D here, and angle C is congruent to angle F, B and E would have to be congruent, right? Because triangles add up to 180, and if those are congruent, these would have to be congruent. That should make sense. So let's use this. Before we use that, same thing, the same properties that we've done before, I can use them for triangle congruence. So reflexive property, I can say a triangle is congruent to itself. Symmetric, if a triangle is congruent to another triangle, I can flip it around. DEF is congruent to a triangle ABC, right? By the symmetric property, you can flip them. And the transitive, remember if I have a triangle congruent to another triangle, and that triangle is congruent to another triangle, then the first and the third would be congruent to each other. ABC would be congruent to X, Y, Z. So if this is the case, then this occurs in the end, right? By the transitive. A equals B, B equals C, then A equals C, the usual. All right, so let's use that. So I'm giving a bunch of stuff here. I'm going to write one. I'm just going to circle all this and say that's coming down here. That's given, just to save you some time. So that's given. And let's mark some stuff on my my picture here. I'll get rid of that. Let's mark some stuff on my picture. L is congruent to P. I can mark those. LM is congruent to PO. LN is congruent to PN. Well, I already used one dash. I better use two dashes here to PN. And MN is congruent to OP. I better use three dashes. Okay? So let's think about this here. To get a triangle congruent to another triangle right now, I have to have all angles and all sides congruent. Well, I have all three sides, don't I? Have that one, have that one, have that one. I got all three sides. So I'm done with that. I need all three angles. I only have two of the angles so far. Can I state any of the other two angles congruent to each other? By looking. Can I state that M is congruent to O, for example, yet? I don't know if I can. Can I state that these two are congruent to each other? Sure, because they're what types of angles? Vertical angles. So I could say angle LNM is congruent to angle ONP. And I can flip that around and say angle PNO or angle MNL. And I know they are vertical angles. So vertical angles theorem or definition of vertical angles, or even if you just say vertical angles, I'm okay with that. Well, now we have that new theorem. I can state that M is congruent to O, because if two angles are congruent, then it makes the third automatically congruent for triangles. So I can say that angle M is congruent to angle O. And that was just what? Let's go back and take a look. That was our third angles theorem, right? If two angles were congruent, that made the third congruent. So third angles theorem. And we're done. And what you're going to notice in the next couple sections is we're going to have a bunch of different ways to state triangles congruent. Well, now I can state that they're congruent, right? I gotta finish this out. LMN is congruent to triangle PON. And basically, all sides and all angles are congruent. So that makes them congruent. Or corresponding parts are congruent. All sides and all angles are congruent. And what we're going to find out in the next couple sections is that we're going to use different things to prove triangles congruent. And we won't need this much work into it. Okay? But for now, I needed to know all that information in order to prove those triangles are congruent. There you go. Got about 6 problems. Good luck to you.